Hi, my name is Romeo Santos, and today I am presenting session Hijacking Web Applications, a controlled lab project focused on how login sessions behave in three separate applications. The bigger picture is how fast applications can be built using plain language and simple prompts. The user tells AI, in our case, what it wants build and how it's going to behave, and then they quickly get a working app. And that's super useful for small businesses, small teams, non-developers, or even experienced developers, and it's a force multiplier. It has a tendency, or an opportunity rather, not a tendency, to potentially skip an important step, which is a security review. And here are a few reasons, in my opinion, why it matters. And there's taken from some research in 2025. We see that studies of a public GitHub repository found thousands of security issues in AI-generated projects. Similarly, there is a notice that insecure patterns can show up again and again, and people are reusing this insecure AI-generated code. Lastly, an industry report shows that a large portion of generated code still contains common security weaknesses. And clearly, context matters, and there's a lot to be said about that. This project is not trying to say that AI generated code is bad or vibe coding is bad. The focus is much simpler. When an app is built quickly, what does its security actually look like before anyone checks it? And I focused on login sessions because that's what keeps a user, or that's what gets a user logged in or signed in after entering a username and password in our case. So. Okay, the project is going to compare, as I mentioned, three apps. One is a standard, which we're going to call the control app. It's an app I received from a GitHub repo, which I didn't clone or download directly from the repo. I opened the files, and then I copied and pasted them and put them in Codex CLI and had the agent recreate the application, front end and back end. And for the last two, the ChatGPT and the Gemini, I used one prompt that gave both of those models the same prompt, and they built a front end and back end. And then I had Codex CLI here on my victim machine, get them all set up and ready to test. So my main question is that if someone captures a valid session, is that information that was captured able to be reused to get into this app without logging in using username and password or credentials? And this matters most because the end user, it doesn't ever see code, doesn't care about it, and all they know is that they have an application that's working and it does what they thought it should do or what it's intended to do. But if security was never tested, some users are trusting something that is not fully checked and could be detrimental. So okay, so let's take a look at our setup. And I mentioned I described each application how it was created. So we have them here. You can see that they're on my victim machine. They all run on their own ports, front end and back end. And in my lab here, I have an Xubuntu as the victim machine and Parrot OS as the attacker machine. On Parrot OS, I'm running OWASP ZAP to act as the proxy in this isolated network that's going to intercept traffic from the victim machine. Okay, and everything is in a controlled, safe lab environment. Okay, so here's our method, and there's some technical information for you, but essentially what it does is that these applications, and rather how they're all tested, is that a user is going to log in, and then there's going to be a capture of some session values and during login, and then reuse of that data is going to be attempted, and then we'll see if access is granted. So it's pretty simple idea. And if the session alone is enough to grant access or to get access, then that is essentially someone who steals it can pose as the user or, say they're the user. So, or how do you say you're the user without saying you're the user? That's essentially what we're looking at. So, okay, so let's switch to the victim machine. That's a mouse right there. Okay, let's open up Firefox. Okay, let's visit the web page. Jesus. We're doing the 8002 app, and okay, so we're at the login screen. Let's switch over to the attacker, Parrot OS, and we'll kind of see what we're working with here. We have OWASP opened up, and it's acting as a proxy, and we see here we have some get methods, and we see that this is the web page that was visited. Okay. Okay, so take a look. I'm going to double click on this and take a look at the response here, or the request. Okay, so really basic information. Nothing has been entered on that web page. And then we got some basic HTML just talking about showing what this website is displaying. Okay, so no cookies sent, nothing sent yet. Very, very basic stuff here. Okay, so now let's go back over to Ubuntu and then log in, or to the victim machine and log in. We're going to log in as admin and enter our password. And let's see, we are authenticated, we're logged in, and we see we have app, log out, welcome back, some information here, right? So let's take a look at OWASP and see what is going on there. Okay. So let us find the information we're going to be needing to inspect here. So we have those initial get methods here, and then we have a post here which shows set cookie. So there's potentially a cookie. Yeah, there's a cookie right there. Okay, so we have the request. Oops, let me double click it. Okay, here it is. We have the request here, and that is where we enter our credentials, and the response is the cookie. Okay, redirecting to that login page. So we are good to go. And so we have a cookie. Let me go ahead and highlight this because we are going to use that here in a second. All right. Okay, so we're going to do two tests here. We're going to open a terminal real quick, and then I have these commands, so you don't have to type this out, and kind of show you what we're working with here. Okay, so we're putting this command in here. We're going to curl. We're going to request information about this URL with curl and tac lowercase I. We're going to get some header information, and then tac capital H as we're going to push this cookie against this URL. So I'm simplifying this, but this is essentially what we're doing. Let me paste it here. And with this information, let's see if we can authenticate. And we are able to authenticate. Okay. So we get the 200 OK. And let's take a look, go back to the Ubuntu machine, and we see we have sign in as admin user. You are successfully signed in. And we're now go back to the attacker machine. You are successfully signed in as user, so on and so forth. Okay, so this is good news. Alrighty, now let's take it a step further and let's open up Firefox and use that cookie here. We're gonna visit the web page and then open up Developer Tools and attempt to replay that cookie session with that cookie. Let's see. Okay. So let's right click. Oops. Open Developer Tools. So we are in fact on that page. Okay. And go to the console, and we're going to have to use that cookie again. So let's go to my little cheat sheet here and copy this, paste it here, and then I have a space here for the cookie value. Let me zoom in for a second. Sorry about that. It's not zooming in. Okay, well, my apologies. So you'll see these commands, what I'm using here in the presentation here in a second. Okay, so let's go back over to OWASP ZAP, copy that cookie once more, paste it right here, push enter, and what are we going to do with that? It's waiting for us to do something with that information we put there. Let's go ahead and push it against this URL here. paste it there and see if we authenticate. Okay. And we have authenticated. That's good news. Okay, so we've authenticated without entering username and password credentials, right? So it's good news. Let's go back to our presentation here. Okay, so here in the presentation, just talking about the demo, you can see a little more clear here the command I use in the terminal and then the commands I use in the console for the console in Firefox. Okay, so let me let you know now. I'm not going to go through all the applications, but every application behaved the exact same way after capturing a valid session. It could be reused to access the protected page. Okay. Okay. So what does it mean? What do those results mean? So the login itself was real. The user logged in manually, and as I demonstrated, the testing tool captured what the app created. That's all it did. And once a session was captured, it worked like a pass, like a physical pass. Hey, I belong here. Let me go ahead and do what I got to do. So, and the system accepted it, and it allowed access without asking for a password. And in simple terms, the app trusted the session, and the app did not verify who was using it. And there's a caveat, a limitation in the lab, is that since traffic was routed through this test system, that may have skewed the results, may not clearly separate users in an actual environment. Those checks could behave differently. And so here's the caveat here. So just kind of take a look at that. Okay. Forgot to click on that. Okay, so the main risk itself is not AI. Clearly that's not it. And it isn't that vibe coders or AI generated code is bad. The risk is that an app can look finished once it works, or in our case, once a login works. So you can look at it from, I guess, there's clearly many more perspectives. But let's look at it from the builder. It says, hey, it works, so it's done. Then the user, they're able to log in, and that's what I wanted. That's what I expected, and it's doing it. But from a security perspective, we know that it has not been tested. And the project shows that all three apps worked as expected, but they all allowed a session reuse, that replay of that cookie, our session hijacking. And the mitigation, so there's tons of mitigation and lots of work to be done and expedited using AI. So let's not discount the benefits of AI. There are several ways to reduce risk. Protecting our cookies, rotating sessions after login. There is HSTS, where let's say, and in our case we're running these web applications over HTTP. HSTS could force an HTTP URL or web application to use HTTPS, let's say for a specific amount of time, for whatever predetermined amount of time, and then review and test the application before release. This is super critical and clearly an important thing to do. And the key idea is a working app still needs security checks before people begin to rely on it. This is the ideal situation, right? So recapping, all three applications produce the same result. A captured session could be reused to gain access the app without logging in. And again, it doesn't mean every generated app is insecure. And there is context. Some development is at a specific stage. It's not meant to be exposed to the internet or for someone to be using it. So the takeaway is I think it's pretty straightforward. A working application is not the same as a secure one. And before a user depends on it, testing, review, and basic protection should be in place. Okay. Well, that's my presentation. I really appreciate your time, and thank you for the opportunity to receive your feedback. Have a good day.